Share screen 3. Okay, cool. So for our third assignment, we are creating a program that is designed to test the Goldbach's conjecture theory. So the Goldbach's conjecture theory is it's two prime numbers, any two prime numbers that add up to every even integer greater than 2. So for our purposes, we're only going to go up to 100. So the range is 4 to 100 because the next even integer after 2 is 4. Okay, cool. So for our first function right here, we need to take care of the issue that 1 is not a prime number. So if n is less than or equal to 1, it's going to return false. Great. That takes care of that issue. And the second issue that we need to make sure is that it's not the prime number that we get is not divisible by anything other than itself or 1. And this is the formula that I have. So it doesn't work unless like I'm only going to explain this with an example because that's the best way to do it. So like let's say if n was 16, so the square root of 16 right here. If the square root of 16 is 4, and then we have a range from 2 to 4. So if 16 divided by the range of 2 to 4, so it's divisible by 2 or it's divisible by 4, that's going to leave a remainder of 0. That means that's not a prime number. That's what this formula is meant to do. This formula is meant to make sure that the numbers that we pull are only divisible by 1 in itself. Okay, cool. And then for our second function right here, it gets the second number. And more importantly, that's identified by Q. So we already have P right here. And then since the Goldbach's theory states that it's every even number, it's an even number or any two prime numbers that add up to an even number. Okay, cool. So this is a little reverse algebra right here. So I have Q is equal to even number minus P, and that's going to return a pair of P and Q. Cool, that's our second block. So first prime number, second prime number, and then this is going to make sure that it adds all up together in the term. So we are calling this function right here. So we do have a range of 4 to 100, which is signified by this little line of code right here. And then if the pair is not none, so what this means is that if the pair is like nothing, it's not nothing, it's double negative, it's going to pull up this. So P and Q is a pair. Then we have prime n is equal our first prime number, and Q is our second prime. Hopefully that makes sense. And then we have all the prime numbers and all even integers greater than 2, all the way up to 100 in the terminal. And every single one of these addition combinations, these are all prime numbers. So it worked. So this pulls the first prime number. Based off that first prime number, this function pulls the second number. Okay, and we are done. It's 3 minutes.